Today's lesson is about concavity. Let's look at the parabola. If you have certain points on the edge of a parabola and we draw tangents on those points, you'll see that these tangents will form a little bowl. And if the bowl is facing upwards, it means that it's concave up. And the formula for concave up is the second derivative larger than 0. You have to learn that. Don't understand it, it's just learn work. Let's look at the negative parabola. If we have tangents around the negative parabola, you'll see that the bowl will face downwards. And then this graph is concave down. And the formula for concave down is second derivative smaller than 0. Now if you look at the cubic function, the point of inflection is the point where the concavity changes. So just before, if we have a positive cubic function, just before the point of inflection, it's concave down. And just after the point of inflection, it's concave up. What is concavity on the point of inflection? Yo, there's no concavity. Right, very good. Now, I want to look at this table. This is math language. And how does this math language sound in English? When my dad goes to the doctor and the doctor throws all these medical terms, my dad will ask him, "Ag sê dit vir my in boere Afrikaans, in normal Afrikaans." So now we're going to translate maths into normal English, boere English. Okay. What does this mean? If I talk about fx, it actually means the y value of that x value. If I give you a first derivative of something, it actually represents the gradient. If I give you the second derivative, I'm actually talking about concavity. Okay. What happens if I set these equal to 0? So if the y value of a function is 0, it actually refers to the x-intercepts. Does that make sense? Okay. If I tell you the first derivative is 0, this first derivative is the gradient. Where is the gradient 0? On the turning points. If I say the second derivative is 0, I'm actually talking about point of inflection. These things you have to go and learn. If I tell you the y value of the function is larger than 0, it means I want to see the picture of the graph which is above the x-axis. If I ask you the first derivative is larger than 0, it's actually the gradient is positive. The gradient is positive when the graph goes in this way. If the second derivative is larger than 0, it means it's concave up, so the picture will look like this. The bowl. Sorry? The I tell you the y value is smaller than 0, it actually means the y is negative, so I'm actually looking at the graph below the x-axis. When the gradient is negative, the graph will go down. And when you have concavity that's negative, it means it's concave down. This table is very, very important. You will get a lot of sums where they won't ask you, give me the turning point. They'll ask you, give me this. Then you must know it's the turning point. Right. So know these by heart and understand what you've learned. Let's look at our first example. The first question, let me rather say, when you do graphs like the cubic function, you will always get questions like this. And now I'm going to explain to you how to interpret these questions. The question will be, for which values of x will fx be larger than 0? That means where will y be larger than 0, or the y is above the x-axis. That's what you need to think. Okay. I drew this one where the y is above the x-axis. So we have that. That's the only place where the y is above the x-axis. Now, because there are two parts, your answer must have an or. The first part, this graph is between -5 and -1. So if you have a between point, your x value is in the middle, the lower value is to the left, and the highest value of x is to the right. And the backies in between is always smaller than. The backies between the two x values will always be smaller than. Let's look at this one. If x goes higher than 6, the y value will be above the x-axis. So x must be larger than 6. The next one. If fx is smaller than 0, it means y is smaller than 0. Therefore, I'm looking for y under the x-axis. This is what you think. Now you must look at your picture. Where is the graph below the x-axis? On those 2 points. I have 2 parts, so there's an or in the middle. This one part has values between 2 points, so the x is in the middle, the lowest value is to the left, and the highest value is to the right. Alright, before I go any further, I want to know, who is bored? Who am I boring now? Because most of you are asleep. This is not how you do maths in grade 12. I can stop you and then everything is self-study. Am I clear? Are you all awake? Are you with me?
Yes.
This is on the video as well. This graph goes to the lower side of the negative x's, so x is smaller than negative 5. This graph is between negative 1 and 6. Therefore, the x is in the middle. If you don't put or in your answer, I'll mark your answers, but you will see something like this. -1 for notation. In matric, that's how they mark. If your answer is right, you get your marks. But if you write something wrong, notation is wrong, or you did something wrong that's not mathematically correct, or you left something out, they subtract 1 mark for notation. So it's not a mark like yeah. Question number 3. The first derivative is larger or equal to 0. That means the first derivative refers to the gradient. Where is the gradient larger or equal to 0? Now, larger than 0 means positive, so I'm looking for a graph that goes up. Equal to 0 means it's a turning point, so I'm looking for the turning point as well. There's my graph. There are my turning point x values. So where is the graph positive, the gradient? Smaller than negative 3, but it includes negative 3 because I want the turning point as well. Where is the graph gradient positive? After 3, 5, but I have to include 3, 5 as well because the turning point must be included. Manolo, are you with me? Okay. Let's look at number 4. Sorry? Terrible week. Number 4. Where is the gradient negative? So where does the graph go down? From that turning point to this turning point, so it's between those 2 points. Therefore, I have the x in the middle. Number 5. Where is the second derivative equal to 0? So I want the point of inflection. I only want the x value. Now this you need to work out. Focus. The point of inflection is halfway between the 2 turning point x's. That means that I have to get the distance from there to there. And then add that distance to negative 3. How do I get that distance? We say 3, 5 minus negative 3 divide by 2. Then I get the distance. I have to add this distance to negative 3 and then you get a quarter. So the x value here at the point of inflection is a quarter.
What if you just get half of the distance?
Half of the distance.
You get half of the distance added to x value.
And then you add it to the smallest x value.
What is the smallest?
All this. Or you can subtract it from the largest one. Okay. Now, question number 6 and question number 8 asks exactly the same thing. You can subtract it from the highest one, or you can add it from the lowest one to the lowest one. Now, question 6 asks concave up. But the same question can be asked differently. Where is the second derivative larger than 0? Those two questions ask the same thing. So your answers will be the same. Where is the graph concave up? I've just determined that the x value of the point of inflection is a quarter. So concave up will be after the quarter, so larger than a quarter. Concave down will therefore be smaller than a quarter. And question 7 and 9 asks the same thing. Are you all here? Example 2. Now I give you a cubic function and I ask you, where is this function concave up and where is this function concave down? What is the formula for concave up? How do I get concave up? Yeah. So concave up means that my second derivative must be larger than 0. You first need to get your first derivative from the cubic function, and then you differentiate that to get your second derivative, and you use this second derivative to say that it is larger than 0. Just remember, when you get your x's alone, up until that point, when you divide or multiply with a negative at vacuumsummer, it changes direction. So the larger than becomes smaller than. Just remember that, don't forget it. Now that we've determined concave up, can we use this and write concave down? Yes, you just swap this. What is a vacuum in English? Inequality, okay. But you know what I mean. In an exam, if they give us A and D, will we get our marks if we just sum in, all of them? We also do follow-up marks. So if this one was wrong, and you say, let's say you said 5 over 16, and the follow-up question is x is larger than 5 over 16. You'll get your mark, but you lose one there. If you didn't see or you didn't know that concave down is just the opposite and you worked it out, you'll get the same answer. Okay, the next thing The last thing that I want to show you, this is not on your notes. It's just a little trick that I want to show you. It has to do with local max and local min. You all agree that that turning point is a local maximum and this one is a local minimum. Do you know why? Okay. If I give you a function, fx, whatever it might be, and I tell you that the x value of the turning point, the x value of the turning point is 1. And I ask you directly, is this a local max or a local min? How will you get to the answer? Okay. I'm going to show you a little trick. Let's look at the local max. What is the gradient of the graph just before the local max? Positive. And just after the local max? Negative. If you look at the local minimum, what is the gradient just before the minimum? Negative. And just after the minimum? Positive. Now, if I tell you the x value is 1, you draw a little table with your 1 in the middle. And then you choose an x value just left of the 1 and just to the right of the 1. So I chose 0 and I chose 2. And if I substitute that into the gradient, you'll get a positive answer. And if you substitute that one into the gradient, you'll get a negative answer. That means that the gradient just before the 1 is positive, so it goes up. And the gradient just after the 1 is negative, so the gradient goes down. So do we have a local maximum or minimum? Maximum. The same goes for the minimum. I'm going to choose the same values. There's my 1. I choose one x value lower and one x value higher. It can be -1 and it can be 5. Then you substitute these into the gradient to see what the gradient looks like. Let's say the gradient gives you a negative answer. It means the gradient was downwards, negative. The turning point is 0. And the gradient after the turning point is positive. So that means this is a local minimum. Do you understand that? It's a nice trick to know. Alright, that concludes today's lesson. Your homework, copy this. I can take a photo and put it on the or you can take a photo. It doesn't matter. No, you can use other methods. Yeah. Yes, put it on the grade 12 group. Yeah.
Actual Telegram group.
Yes, that one. Concavity. We did examples 1 and 2. Your homework is exercise 8, page 37, number 1, 2, 3. Are you